If you think Jupiter is massive, think again. Jupiter is already a monster, big enough to hold 1,300 Earths inside it. The king of our solar system, a world of endless storms and swirling clouds. But far beyond our sun, astronomers have found a planet that makes even Jupiter look small. A world so huge, and yet so light, it almost shouldn't exist. But before we get to this cosmic giant, let's start from home, Earth, and take one step up at a time into the world of the giants. Earth versus Jupiter. Earth's radius is about 6,000 kilometers, big enough to hold oceans, mountains, and life itself. But next to Jupiter, we are nothing. You could fit 1,300 Earths inside it, and still have space left for a few moons. Jupiter stretches more than 11 times wider than Earth. It's a world of extremes, no solid surface, storms that rage for centuries. And the Great Red Spot, a hurricane so large, 3 Earths could fit inside. In the solar system, Jupiter is the first true giant. But what if I told you there's another world far beyond our system that makes Jupiter look like a marble next to a beach ball? Let's meet HAT P67b, Jupiter versus Chat P67b. Discovered in 2017, Chat P67b is a gas giant located about 1,200 light-years away, in the constellation Hercules. Its size is staggering. It's about 2.1 times the radius of Jupiter, roughly 150,000 kilometers wide. But here's where things get even stranger. It's less than half of Jupiter's mass, only 0.34 Jupiter masses. That means it's enormous, but incredibly light. Astronomers call it a puffy planet. To give you an idea, if you could somehow place HATP 67b in an ocean large enough, it would float. It's the largest planet ever discovered by radius, yet one of the least dense objects we've ever found orbiting a star. So how can something so massive be so light? Where it's located. HAT P67b orbits its star, called HAT P67, an F-type star that's hotter and brighter than our Sun. The planet is extremely close to it, only about 0.065 astronomical units away, which is 10 million kilometers. For comparison, that's nearly 6 times closer than Mercury is to the Sun. Because of that, HATP 67b completes one full orbit in less than 5 days. That means a year on HATP 67b lasts less than a work week on Earth. Its star shines 12 times brighter than the Sun and is about 2.5 times larger. Being that close is a death sentence. Boiling and bleeding, torn apart by radiation, heat and size. So how can a planet be so big? Objects this large shouldn't even exist. The secret is heat, extreme, relentless heat. Planets like HATP 67b belong to a group called hot Jupiters. These are gas giants that orbit extremely close to their stars. Because of that, they are blasted with energy that heats and expands their atmospheres. The gas expands and the planet swells up. For HAT P67b, that heat reaches around 1,900 Kelvin, or about 1,630 degrees Celsius, hot enough to melt metal. The star's radiation ionizes the gas, stripping away electrons and supercharging the planet's upper atmosphere. It becomes a world puffed up like a balloon, its gases constantly escaping into space. Astronomers call this the hot Jupiter inflation effect. The closer a planet orbits its star, the more energy it absorbs, and the more it swells. But HATP 67b pushes this to the extreme. Its atmosphere isn't just expanded, it's evaporating. Telescopes reveal it's losing about 10 million tons of gas every second. That escaping gas forms a massive cloud around the planet, mostly hydrogen and helium. The cloud stretches like a comet's tail, reaching up to 6 times the size of Jupiter. That's not just big, that's unreal. The fragile giant. Think about it. A planet more than 150,000 kilometers wide, yet lighter than Saturn. A year shorter than 5 days. Surface heat over 1,600 degrees Celsius. Winds move faster than sound. If it orbited our sun, its edges would brush the orbit of Mars. And despite being the size of a small star, it's so fluffy that you could, in theory, make it float in water. But HATP 67b isn't just big, it's unstable. Because of how close it is to its star, its gas is constantly being stripped away. Every second, the planet loses part of itself to space. Over time, it will shrink, fade, and finally be devoured by its expanding host star. In a few 100 million years, it will be gone for good. A giant so large, it's doomed by its own size. One of the most fascinating discoveries ever made. Why it matters. HATP 67b blurs the boundary between planet and star. Too big to be normal, too light to ignite like a sun. Its existence forces scientists to rethink how planets form. It probably started far away, then drifted inward until its own star began to destroy it. And one day, it will. The lesson of the giant. Let's step back for a second, from our world to one 23 times larger. Yet all that size hides fragility. This planet is massive, yet light, burning, yet dissolving, a balloon hovering too close to a flame. We often think size means power, but in the universe, even giants can be fragile. HATP 67b proves that under the right conditions, a planet can grow so large it begins to fall apart. It defies what we thought a planet could be. It floats where no world should. It shines even as it disappears. Because in the end, the universe doesn't run out of surprises. There are still worlds out there that defy everything we know. And HATP 67b is one of them.